Okay, we're going to start the Chapter 4 test review. Number 1, we're going to graph the equation, label the y-intercept, the vertex, and the axis of symmetry. We plug the equation into our calculator and then go to table and search for points that will fit on our graph. And it looks like only 0, 0, 1, 5, and 2, 0 will actually fit on this small of a graph. So here's what my parabola will look like, and I will need to label the y-intercept, the vertex, and the axis of symmetry. So the y-intercept would be 0, the vertex is at 1, 5, and the axis of symmetry is the line x equals 1. Number 2, we're going to determine whether this function has a maximum or a minimum value and find that value. Since a is -3, it's in standard form and a is -3, I know that it's going to open down and because of this negative sign. So I know it's going to have a maximum. Let's go and see it, put it in the calculator and figure out what that value would be. Once I've got it in the calculator, I can go to the graph just to prove it to myself while I'm zoomed out a little bit. That it opens down, so it's going to have a maximum. And then if I go to the table, maybe I can figure out what that is. Where do my y values peak out at? Well, they start out -23 in this screen, and then it starts getting bigger, and then at 1, 4, it maxes out and then starts getting smaller again. So 1, 4 is the vertex, and that's also going to be the maximum value. 4 would be the maximum value. So the maximum value would be, we would have a maximum that would be at 4. The biggest the y values ever get is 4. Number 3, we're being asked to find the exact roots of this equation. We're supposed to graph it, and if the roots are not integers, then we need to find the consecutive integers between which the roots can be located. So the first thing I need to do is get it in standard form, or set it equal to 0, which means I'm going to subtract 6x and add 8, and this is what I end up with. So when I put this into the calculator, and I go to the graph, it looks like it might hit at nice even numbers, at nice integer values for the roots. But I'm going to go to the table and make sure wherever the y value is 0, those are going to be my roots. So I have roots at 2, 0 and 4, 0. Both of those are on the x-axis, 2, 0 and 4, 0. So let's plot all these points and graph the function like it asked, and then those will be my roots. So once I graph the parabola, I could graph 1, 3. I didn't have room to graph 0, 8. I graphed 1, 3, 2, 0, 3, -1, 4, 0, and 5, 3. And then 2, 0, and 4, 0 were my roots. So those are also the solutions. X equals 2 or x equals 4. Those two values in the original equation would solve it. Or number 4, I'm asked to solve this by factoring, so I'm going to use the box method. You could use another method to help you factor, but I'm going to use the box method. So when I put the 5x squared in the top left and the -6 in the top in the bottom right, and these two other diagonal empty boxes have to add up to 13x. Now, there's only one way really to get 5x squared, and that's a 5x times an x, because 5 is prime. So I need two numbers that will multiply together to give me -6. So I'm looking at like 2 and 3 or 6 and 1. After playing around with the different numbers, I think 5x minus 2 and x plus 3 is my combination. When I multiply across and down, negative 2 times x will be negative 2x. 3 times 5x is 15x, and then negative 2x plus 15x gives me 13x. So that is what this is going to factor into. So when it factors into 5x minus 2 and x plus 3, and that still equals 0, so then the zero product property says that, well, then I can break this up into saying 5x minus 2 equals 0 or x plus 3 equals 0 and solve those separately for the two solutions. So add 2, divide by 5, you get 2/5. Simply subtract 3 from both sides and you get negative 3. So my solutions are 2/5 and negative 3. For number 5, I have a rectangle that has a length of 7 inches longer than the width. And the area is 144, and I have to figure out the dimensions. So let's draw a picture. We have the width, and the length is 7 inches longer than the width. So I don't know what the length is, and I don't know what the width is. All I know is that the length is a little bit bigger than the width. And I know that the area is 144, which means area is length times width. So usually length times width is 144, but 7 plus W is my length. So when I multiply those two together, I get that. Now if I can solve this for W, I can find the width, which will then let me find the length. So I'm going to set it up into standard form. And then I'm going to try to factor it. So I need two things that will multiply together to give me 144 and have a difference of 7. So as I start to factor W squared plus 7W minus 144, we need the calculator's help a little bit. 144 is divisible by, I need two things that are, two numbers that are 7 apart. Let's see if it's divisible by 8. 8 and 18, those are 10 apart, so that's too many. Let's see if it's divisible by 144. See if it's divisible by 12. Oh yes, it's 12 and 12. All right, so 144. What about 9? 9 and 16. So 144 is the same as 9 times 16. Okay, so if I have 144 and as a factor of 9 and 16, and I need to get a plus 7W in the middle, then that means I'm going to make this one positive and this one negative. That'll give me a negative 144 when I multiply those together. It'll give me a positive 16W and a negative 9W, which will give me a positive 7W when I add them together. And of course, I still have my W squared in the front. So that means that if this is the correct factoring, then W minus 9 is equal to 0, or W plus 16 is equal to 0, which means that would mean W would be 9, the width would be 9, or the width would be negative 16. Well, it's not possible for the width to be negative, so that is not a possible solution. So my width is 9. And so if my width is 9, and my length is 7 plus my width, then that means that the length must be 7 plus 9 or 16. We're going to skip 6 and 7. On number 8, we're going to write a quadratic equation with -6 and 3/4 as its roots. We're going to put it in standard form so that a, b, and c are integers. So if those are the roots, so if x equals -6 and or x equals 3/4, then if we set those equal to 0, that means x plus 6 was equal to 0, and x, let's see, 4x minus 3 was equal to 0. Okay? So then if I multiply those together, because if I go backwards, I'll multiply both sides by 4, and that's a 4x, and then I subtract the 3, and I get that. So then I go backwards into my quadratic, and it's an x plus 6 or a 4x minus 3 equals 0. And then when I FOIL, I get 4x squared minus 3x plus 24x. 3 times 6 is 18 minus 18 equals 0. And now all I need to do is combine my middle two terms together, and I get 4x squared plus 21x minus 18 equals 0. And I have integers. Number 9, I'm going to use the square root property. Notice that that is a perfect square, because when I take 6, cut it in half, and then square it, I get 9. So that means that this will break up into x plus 3 times x plus 3 equals 25. And then when I take the square root of both sides, which is the square root property, then I get x plus 3 equal to plus or minus 5. So which means x would be -3 plus or minus 5. And my two answers would be -3 plus 5, which is 2, and -3 minus 5, which would be -8. For completing the square, I need the left side of my equals equation to be a perfect square. So I'm going to go ahead and get rid of the 9 for now. And then I need to decide how much I need to have here in order for all of this to be a perfect square. So if I take b, which is 4, cut it in half and square it, I get 4. So I'm going to add 4 to both sides. So that will break down into x plus 2 squared, and that will be equal to 13. Now I take the square root of both sides. I get x plus 2 equal to square root of 13. And subtract 2, that'll be plus or minus. So x equals -2 plus or minus square root of 13. For number 11, you need to do the same thing. I'm going to add 2 to both sides, so I end up with 2x squared plus 3x equals 2. I also need to factor off this 2 in front of the x squared. So that'll leave the 2x squared plus 3 over 2x equals 2. Actually, that's vertex form. I'm going to divide everything by 2 and get x squared plus 3 over 2x equals 1. So then the amount that I need to have here, the amount that I need to add to this needs to be, to make this a perfect square, needs to be 3 over 2 cut in half and squared. So that's 3 over 4 squared, which is 9 over 16. So I need to add 9/16 to both sides. Now 1 plus 9/16 as 1 is the same as 16 over 16, which when I add those two together I get 25 over 16. And then this left side factors into x plus half of 3/2, which is 3/4. So x plus 3/4 squared equal to 25 over 16. Take the square root of both sides, and I'm left with x plus 3/4 equal to square root of both sides leaves me with 5 over 4, plus or minus 5 over 4. So subtract 3/4 from both sides. X would be equal to negative 3/4 plus or minus 5/4. So our two answers will be negative 3/4 plus 5/4, which would be 2/4 or 1/2. And then negative 3/4 minus 5/4, which would be negative 8/4, which would be negative 2. So those are my two solutions. Number 12, I'm asked to use the quadratic formula. So the first thing I need to do is set that equal to 0. So subtract 3x, add 2 to both sides. Then identify a, b, and c. A would be 5, b, negative 3, c is 2. Then I plug those into the quadratic formula. Negative b plus or minus square root b squared minus 4 times a times c all over 2a. And then simplify. Simplifies down to 3 plus or minus square root of negative 31 over 10. Negative 31 as my discriminant. Being negative means I'm going to have imaginary numbers. I'm going to take the I, take the negative sign, and bring it outside as an I. 31 is prime, so this is going to be left as 3 plus or minus I root 31 over 10. For number 13, I need to just find the value of the discriminant, and then that will tell me how many and of what type the roots are. So the discriminant formula is b squared minus 4ac. Once I identify a, b, and c, then I plug that in, I get negative 12 squared minus 4 times 9 times 4, which turns out to be 0. So if my discriminant is 0, that means I have one real root. That's my discriminant. Now, number 14, same thing. I need to set it equal to 0, and then identify a, b, and c, and plug them into my discriminant formula, and I get negative 9 squared minus 4 times 4 times 3, which is 81 minus, that's 12 times 4 is 48, which is 81 minus 48, which is 33. So since it's a non-negative, non-zero number, that means I'm going to have two real roots. Number 15, I need to find the vertex, axis of symmetry, and direction of opening. Now, this equation is already in vertex form. So h would be -5, k would be -7. So that means my vertex is at -5, -7. And that also means that my axis of symmetry is at x equals -5. And since that number is negative, that means it's going to open down. So on number 16, I want to write an equation for a parabola that has a vertex of 2, -1, and a y-intercept of 5. Well, if I use vertex form to write this equation, that's going to be h, and that's going to be k. So if I write vertex form, I would write it as y equals, and I don't know what a is yet, but I know it's going to be x minus 2 squared minus 1. Now, if I use the point 0.05, I can figure out what a would be. I put 0 in for y, and 5 in for x, and then solve for a. So that simplifies. 5 minus 2 is 3, squared is 9, 9a minus 1. Add 1 to both sides and divide by 9. A will be equal to 1/9. Need to back up. I put 0 and 5 in the wrong place. 0 is my x, 5 is my y, so it should be 5 equals a times 0 minus 2 squared minus 1, which becomes 5 equals -2 squared before a minus 1. So I need to add 1 to both sides. I get 4a equals 6. Divided by 4. A would be 6 over 4 or 3 over 2. So I go back up here and I replace the a with 3 over 2, and that becomes my equation. I'm going to write this in vertex form on number 17. I'm going to separate out the x squared minus 6x. I need to figure out what amount I need to have inside the parentheses in order to make that a perfect square trinomial. So I take the -6, cut it in half, square it. That'll be -3 squared, which would be 9. So I need to add 9, but I also need to subtract 9. I'm on the same side of the equation, so I have to keep it balanced. Whatever I add, I also have to take it away that same amount to keep it equal. But that breaks up into x minus 3 squared minus 1. On number 18, I'm going to rewrite this equation with the y and x, and then just make sure I remember that y is the height of the rocket, and x is the time that since it left the ground. Then I'm going to go use the calculator. Modify the window to show exactly, just kind of narrow down to what the parabola would look like in our set of positive time and positive height. Put it into the equation. My window I set up for a maximum of 5 seconds. Height y max about 60 feet. So then the graph looks something like that. So when I go to my table, okay, the height, I'm not going to have negative. X is my time. So at 0, it's 15 feet. 1 second, 47 feet. 2 seconds, it's back at 47 feet. So that means somewhere in between, if I change the table by halves, and when I go to my table, I see that the height, which is over here, goes 15, 35, 47, 51. I know that's going to be my vertex, and then back down to 47. So at 1.5 seconds, it was at a height of 51.